In the last class, we have discussed about flip-flops. If I am not audible or if you have any problem, you can ask at any time. We have discussed about flip-flops, and then we have discussed about T flip-flop, that is similar to JK flip-flop. The only thing is that you have to mix or you have to join J and K together to form T flip-flop. And we also have discussed how to realize one flip-flop from another, how to construct one flip-flop from another flip-flop. So how to construct one flip-flop from another flip-flop, that will be important for your exam, because I am not going to ask what are JK flip-flop, how does it work. Okay, I'll be asking only the design portion only. So similarly for counters also, I will not ask anything which is directly available in the book. I will not ask. I will try my best not to ask anything which is directly available in the book, because it is going to be online exam, so your understanding is required. You can copy from anywhere, from internet source and all these things. So whether you understand or not, that matters. Only those students who are able to understand, they can answer to the questions. Now, let us go to counters. Counters. Counter is just a digital circuit which is used to count your numbers. As the name suggests, counter means what? You are going to count. It is used for counting. So counters, they also comes under sequential circuit, because these counters are going to be constructed using flip-flops. So these counters are also sequential circuit. They are not combination circuit. And counters can be divided into, classified as asynchronous and synchronous counter. Asynchronous counter means what? All the flip-flops are not synchronized. Means all the flip-flops are not activated at a time. One flip-flop, output of one flip-flop will trigger the next flip-flop, and output of the next flip-flop will trigger the another flip-flop. Like that, it goes on. That is called asynchronous, where there is no synchronization. The output of one flip-flop will trigger the another flip-flop, and it goes on. Whereas in case of synchronous counter, the name synchronous is there. So what happens? You will have clock pulse in all the flip-flops. All the flip-flops will get trigger at a time. Can you understand? Synchronous flip-flop means, synchronous counter means all the flip-flops which is available in the counter synchronous counter means all the counters will be triggered by clock pulse, and all the flip-flops will work together simultaneously. We can also classify counters as a single mode, multi-mode counter. What is the meaning of single mode and multi-mode counter? Is that single mode means it can count only in a single mode. That means what? It can count from 0, 1, 2, 3, 4, 5, 6 like that. Upwards it can only count 0, 1, 2, 3, 4. Or downwards like 100, 99, 98, 97, 96. Or say from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 like that. What about multi-mode? Multi-mode counter means it can count a counter which can count from 0 to say 10, and also it can count back from 10 to 0. That is called multi-mode counter. Modulus counter. Modulus counter means we call it like a particular counter can it count from 0 to 5. So 0 to 5 means what? Including 0, 0 to 5 means we are having 6 states, 0, 1, 2, 3, 4, 5. 0 to 5 means we have 6 different states. So it's a mod 6 counter, we'll call it. Because mod 6 counter means what? It can count up to 6, 0 to 5. It will have 6 different states. So it's called modulus counter. Okay, mod 6. Mod 8 means it can have 8 different states. Mod 10, it can have 10 different states. So 0 to 9 is 10, like that. Mod 5 means 0 to 4. So that is called modulus counter. So now, how counter is being constructed? I will go a little bit fast. If you don't understand, you can ask. This is your 4-bit. This is your, you can write down, the name is not given here. This is asynchronous counter. This is not a synchronous counter. This is an asynchronous counter. So when I say asynchronous counter, you can see this is a flip-flop, JK flip-flop. This is the output QA, QA bar, QB, QB bar, or like that. We have 4 numbers of flip-flop. J and K connected together. J, K connected together. Everywhere JK is connected together. And is given to VCC. That means J is 1, K is 1. J is 1, K is 1. J1, K1, J1, K1, everywhere. That means every flip-flops will toggle. When J is 1, K is 1, output get toggles. So output will toggle, output will toggle, output, all the 4 outputs will get toggle. And you can see that you are giving a clock pulse, and there is one bubble. This indicates that it's a negative edge trigger. As I said, if there is bubble, it should be negative edge. And we don't have any clock here. This JK flip-flop required a clock pulse, and this clock is being fed by means of this particular output. This output is given as a clock. Similarly, this output is given as a clock, and the same is also taken as an output. This output is given as a clock, and the same is also taken as an output. Here, we don't have any other flip-flop, so we have the output here. So this is 4 numbers of flip-flops. If I have 4 numbers of flip-flops, and I know every flip-flop can store either 1 or 0. So if I have 4 numbers of flip-flop, then I can consider it as a 4-bit counter. It can have 4 number of bits. Every flip-flop can have 1 bit. So it is a 4-bit counter. It is written 4-bit binary ripple counter. So it is the name of a ripple counter because the output of one flip-flop is given as a clock, output of another flip-flop is given as a clock, so it looks like a ripple. So it is called as a ripple counter. But this whole counter comes under the category of asynchronous counter because clock is given only in one particular flip-flop. Here we don't have any clock. This clock is not given in this particular flip-flop. This clock is not given in this flip-flop. This clock is not supplied in this flip-flop. Rather, the clock of this particular flip-flop is given by the output of the previous flip-flop, and therefore this is an asynchronous counter. Any question?
No, sir.
No question. Now, as I said, it is a negative edge trigger. You just see this is negative edge, negative edge, negative edge, negative edge, negative edge. All are negative edge. So now, in order to examine, here is one negative edge. And we say, let us assume that all are 0 in the beginning. And to be very careful, you should always, when you draw the counter like this, then this particular flip-flop output will be your least significant bit, and this output will be your most significant bit. When I write a number 1011, this is your least significant bit, and this one is your most significant bit. So this 1011 is nothing but 11 decimal. This is 11. So this 11 is written in binary 1011. So this is your LSB and this is your MSB, as you know. But in case of this arrangement, this side is your MSB. This side is your LSB. Okay. So when this is 0, 0, 0 in the beginning, when you have a clock is given. Clock is given, negative S, yes, negative S, this is negative S. So when clock is given, this J is also 1, K is also 1. If J is 1, K is 1, earlier output is 0, earlier output was 0, earlier output was 0, earlier output was 0. Now, next. Next, when input is given, when clock is given and input is already connected to VCC, now next, what will be the output? The output will over here will be 1. Over here will be 1. Why? Because the output should get toggled. Previously it was 0, now it should be 1. Why? When clock is given, J and K is 1, 1. So the output should get toggle. What about this output, next output? This 0, 0, 0, 0 by red color is the previous one. Now the new output over here will be what? What will the output of Q be? Am I audible?
Yes, sir.
Yes, sir.
What will be the output of QB? QB output?
It will be 1, sir.
You know JK flip flop. This one is one bubble, so it is triggered. This output 1 is triggering. Okay, negative is. So it is 1, then one bubble is there. So now, what will the output of this? The output of this will be 0. Why 0? No change. Previously 0, next also 0. Why no change? Because the input of this flip-flop, JK flip-flop, the input is what? Input is what is the input? J is 1, already connected. Always J1, all are J1, K1 already. J is 1, K is 1. J is 1, K is 1. Can you understand? And then this clock, this is the clock. And clock is a negative edge. Negative edge means when it is down, then only it should trigger. So now it is 1. So 1 is not the way. 1 will not trigger. So if this clock is as if there is no clock. If there is no clock, then the output will be just like the previous output. Just like the previous output. Just like the previous output. What about this?
QC will be 1, sir.
Well, am I making mistake at the time of explanation? So clock is no. This will be 0, and this is already always focused in 1, 1, 1, 1, 1, 1, and this is 0. So 1 and 1, 1 and 1, from 0 to 1. Transition is there, 0 to 0. 0 to 0 now 0, and 0 to 0 to 0, 0 to 0 is no transition, so 0 0 no transition there, so it will be 0. Now 0 to 0, 0 to 0, no transition is there, so it will be 0. And then let me analyze. Okay, by seeing the waveform it will be very easy, but I want you to understand that is the thing. Anyway, now let me now what is that? Now again another clock, the third clock. In the third clock, this is 1 and 1, this is 1 1, this is 1, this is 1, so I will toggle 0 to 1, 1 to 0. The output toggle from 1 to 0. 1 to 0 means 1 to 0. 1 to 0 means 1 to 0. 1 to 0. 1 to 0 means 1 to 0 is a transition. 1 to 0 is a transition. If there is a transition from 1 to 0 is a negative, this will become alive. And then when this is 1 1, so I will toggle 1 1. 0 to 1. 0 to 1 means this is not alive. This is 0 to 1 transition. So even if it is 1, it will be 0. 0. There is no transition. This is not alive. So it will be 0. So the output will be, earlier it was 0 0 0 0. In the next cycle it was 1 0 0 0, and in the next it will be 0 1 0 0. So 0 0 0, this is your MSB. 0 0 0 0, yes, correct. 1 0. This is MSB. This is means 0. This is your MSB, and this is 1. This is MSB, so 1 0 means 2, like that. Okay. So let me explain it. From before going to the circuit, if I explain from the waveform, it will be very easy. I will explain it from the waveform first, in order to make sure that it is not difficult, it is easy. Otherwise, you will think that it is very difficult. See, when you see the diagram very carefully, you will come to know that all the flip-flops are negative edge trigger. Bubble is there. Okay, fine. That is true. And you will see that one flip-flop is triggered by the output of the other flip-flop. One flip-flop is triggered by the output of the other. That is also okay. That is also, I agree to it. Then you just see the clock pulse. This is the negative edge, this is negative edge, this is negative edge, this is negative edge, this is negative edge. These are all my negative edges. Okay, this is also no problem, no doubt. Now earlier it was 0 0 0 0 0 0 0. No doubt. This is also no doubt. When this clock pulse comes, the first clock pulse will trigger QA. That means flip-flop number A will be triggered. Okay, so flip-flop number A, it will toggle. Clock has come. Yes, clock has come. And always the input are connected to 1. JK is always 1. JK1 means toggle. Earlier it was 0. Now it toggles. Can you understand? It toggles. And when the another clock pulse comes, negative edge clock pulse comes, it will again toggle. And then when another clock pulse comes, it will again, another clock pulse comes, it will toggle, and it will remain as it is. And clock pulse comes, it will toggle. Toggle means from 1 to 0, and it will remain in 0 till another clock pulse. It's coming, so it will toggle. Can you understand what I'm saying? Can you understand?
Yes.
The first flip-flop will toggle. Can you understand?
Yes, sir.
So since the first flip-flop is connected to the second flip-flop, the first flip-flop is connected to the second flip-flop, and at the output of the first flip-flop, is the clock to the second flip-flop. So the output of the first flip-flop, what is negative edge of the first flip-flop? This is negative edge, 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 this is negative edge. This will trigger the next flip-flop. So another flip-flop, it was already, the next flip-flop is 0. It remains 0. Why? Because it is not triggered. trigger has not come. Yeah, now the trigger has come. Now it will toggle. Output will change from 0 to 1, and it will remain in 1 till another pulse comes. Yes, another edge. So it will toggle. It will go down and remain down, low till another comes, and it will high, low, high, low. It will go like that. It's okay.
Yes, sir.
Yes, sir.
So now,
Yes, sir.
and now flip-flop number C is toggle. It means like it is activated. The clock pulse user see, it is given from the output of QB. So QB is going to be the clock of flip-flop number C. So flip-flop number C, this is the QB output is going to be just like his clock. So what is it? Negative A is this one, negative A is this one, negative A is this one, negative A is this one. So this will trigger the third flip-flop QC. So it was 0. Now it will it change? No, it will not change. Q. Why? Because it has trigger has not come. Now it has become trigger is here. So trigger has come at this time. So it will toggle from 0 to 1. Because when J is 1, K is 1, for all the flip-flop, J and 1 are always given 1, connected to 1, till BCC. That means J is 1, K is 1. If J is 1, K is 1, output will keep change, that is toggle. So it toggles here, and it will remain high until it gets another pulse. Yes, another pulse is coming, it will toggle, it will go down and remain down, low until another clock pulse. So it goes high, and it goes like this. Is it okay?
Yes, sir.
Yes,
Yes,
sir.
sir.
So now, the last one, the last flip-flop will be triggered by the third flip-flop. So third flip-flop, negative A means this one, this is negative A, another negative A means this one. So the last flip-flop will not change. क्यों change करेगा? क्योंकि इसको तो clock मिला नहीं. Edge is not, it has not found any negative edge, no negative edge, no negative edge, no negative edge. It will remain as it is. Oh, negative edge has come, so I will toggle, I will change. From 0 to 1, it changes, and it stays at 1, 1, 1, 1, 1 till another clock pulse comes. Can you understand? So this is the waveform, and when you see it is 0, 0, 0, 0, and this is 1, 0, 0, 0, and this is 0, this is high 1, this is 0, 0, and this is what? High, this is 1, this is also 1, this is 0, this is 0. So when you see this is 0, this is 1, this is 0010 is 2, 0011 is 3. Can you understand? This is decimal 0, decimal 1, decimal 2, decimal 3. So it looks like a counter. It is counting. Is it okay? So this will be, this is also high, this is also high, this is also high, this is also high. You just see from here to here, from here to here, this portion high. This is 1 clock pulse, high, 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 high. So this is 15. So going from 0, 1, 2, 3 up to 15, it will count. Can you understand what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
Because from the output, from the output pattern, I can say that this is 0, this is 1, this is 2, 3, 4, like that, binary to decimal. I can convert by myself, and then I can say that, oh, this looks like, so which one is your LSB? This is your LSB list. This is your MSB. Over here also. See, 0001 means 1, 0010 means 2, 0011 means 3. So this side is the LSB. So QA is LSB. That's why QA is your LSB, and Q of D is your MSB, most significant bit. So you should not be careful, be very, very careful over here. Otherwise, the whole thing will get wrong. Okay, because why? Because we know very well that this clock pulse is going to trigger the first flip-flop, and output of this flip-flop number A is going to be the clock pulse of the next flip-flop. So likewise, I'm just drawing the waveform. One will trigger another, another will trigger another, another will trigger another, like that. So now, one thing also I can observe, the frequency, how many cycles in 1 second, let's say there are 0 to 15, I'm counting, 0, so there are 16 cycles. 16 cycles. 16 cycles means what? This is 1 clock pulse from 0 and then high and then 0. This is 1 clock pulse. This is under clock pulse, under clock pulse, under clock pulse, under clock pulse. 1 time period means what? From here to here is 1 time period. No, from here to here is 1 time period. You know very well. So from low to another, this one is time period, time period, another time period. From here to here, another time period. From here to here, another time period. Another time period. From here to here, another time period. From here to here, another time period. So we have 16 cycles. That's That means number of cycles 16 per second. Let's say this is 1 second. For example, from 1 to 16 is 1 second. For example, so 16 16 cycles per second. That means we can say the frequency is 16 number of cycles per second. The clock frequency is 16 cycles per second. Per second means I'm just assuming. So for sake of simplicity, 16 cycles per second. Now you just see QD, output of QD is having how many cycles? Just 1 cycle. QD is having how many cycles? From here you start up, just down. So this is 1 cycle. Can you understand what I'm saying? The output of QD is just 1 cycle. Is it okay? Can you understand?
Yes, sir.
Yes, sir.
So QD, so your clock, for example, I'm having 16 cycles per second, 16 hertz. And your Q of D, your MSB, Q of D is MSB, most significant bit. When you see the waveform of QD, it is just 1 cycle, 1 hertz, 1 cycle per second. It is just 1 hertz. That means if you have a clock of 16, you are dividing 2 to the power 4, and you can divide. From here I can derive one relations. If I have, this is an example, if I have 16 numbers of cycles, then 16 divided by 2 to the power 4, 2 to the power also 16, which is equal to 1. That means I can divide the frequency of the clock down to 1. Earlier it was 16, I can divide down to 1, minimum to 1. Maximum was 16, minimum to 1. How? This will be the number of flip-flops. How many flip-flops we are using here? 4. So 2 to the 4 I put. What is the count? 16 number of cycle, 16. So that means you can divide the frequency down to 1. If you have 16, then you can divide it down to 1. If you have all 4 numbers of flip-flops. Can you understand what I'm saying? So can you understand what I'm saying? So it can be used as a frequency divider. This, we call it as a counter. At the same time, you can call it as a frequency divider. QA will divide frequency by how much? By 2. How? 16 divided by, if you have only QA, means only 1 flip-flop, 2 to the power 1. 2 to the power is 1. 16 by 2 is equal to just 8. 8 number of cycles. Yes, there is 1 cycle, 1 from here to here, from here to here, another 1, 2, 3, 4, 5, 6, 7, 8. QB, QA and QB together, then it should be 2 to the power 2. 2 to the power 2 is what? 4. 4 means what? 16 divided by 4, 4. You have only 4 cycles. Yes, from here to here is 1, from here is 2, 3, 4. Can you understand what I'm saying?
Yes, sir.
You can divide the clock frequency based on the number of flip-flop you are using. If you have 4 numbers of flip-flop, you can divide by 2 to the power 4. 16 times you can divide. If you have 3 flip-flops, then 2 to the power 3. 2 to the power 3 is what? 8 times you can divide. Like that. So this is what you should know. But how the circuit looks like, how the circuit is working, sir, that you are not explaining. You are simply explaining based on the waveform. Yes, I am explaining based on the waveform for you to understand. Now, let us come to the circuit and let us try to understand at least 1 or 2 cycles, how it looks like, how it does, so that we can understand in the circuit. And in the waveform, it is very easy. So in the waveform 1, we will simply draw the waveform, clock, pulse, and all these things. And we will say that 1 will be the clock for the other, the 1 output will be the clock for the other. And we keep doing those things. So it is very simple. Now in exact circuit, how it is behaving, let us check. We know that JK flip-flop, when J is 1, K is 1, the output will toggle. That is the only concept we are going to use. Output will toggle means output will get 0, and when another pulse comes, it will get 1. When another pulse comes, it will get 0 again. 0, 1, 0, 1, it will keep on jumping, shifting from 0 to 1, 0 to 1, based on the clock pulse. But according to the diagram, what is the clock pulse? The clock pulse is when I receive a negative edge. When I receive a negative edge. Negative edge means what? From 1 to 0 transition. Negative edge means, am I correct? From 1 to 0 transition is negative edge. Yes. 0 to 1 transition is positive edge. Negative means it is coming down. So this is from 1 to 0 transition is a negative edge. When 1 to 0 transition, then only the device or the flip-flop will get activated when the clock transition is from 1 to 0. Can you understand what I'm saying? This is from transition 1 to 0, high to low, high to low. That's why negative is it all right?
Yes, sir.
Yes, sir.
Okay. Acceptable. If you don't accept, then if you have confusion, you just tell me. So this is negative S. Negative S means from 1 to 0 transition, only a very short period of time. Now let us think that earlier it was 0. Earlier here, this output is 0. I am not able to write here. So I'll write here because I'm going to analyze many things. So let earlier be 0, and earlier this output is 0. So your A is 0, your B output QB is 0, your C is 0, your D is 0. Earlier, okay. Someone is trying to join. This type of things I really hate because it is wasting my time. Now let's say negative edge transition clock has come. On negative edge, see, clock will be keep supplying from a clock supplier, what's a function generator, we call it function generator, or clock. This is a waveform. This waveform, you will keep on giving the waveform continuously to this. So one negative will come after one cycle, another negative will come after another cycle, another negative will come after another cycle, another negative, keep on coming. So first, let us say that one negative cycle has come from 1 to 0 transition. That is why this will become alive. This will become alive. When this becomes alive, this flip-flop become alive. What happened? This flip-flop become alive. What happened? 1 is given here, 1 is given here. What will be output here now?
Where, sir?
0.
Output at QA. A means
It will be
QA.
1.
1, yes.
1.
Output will be 1 because earlier it was 0. Now it will become 1. It will toggle because J is also 1, K is also 1. J1, K1 is always J1, K1. But always see, you just see J1, K1. J is always 1, K is always 1. I will not allow anyone to enter. Someone is trying to log in. I will not allow. It is already 3. They are disturbing. So J is 1, K is 1 is fixed for all the flip-flops. And this flip-flops only will get alive because it is getting the trigger from 1 to 0 transition. From 1 to 0 transition, that is what edge, positive, negative edge, only at this transition period. What is there? Or J is 1, K is 1. So we'll toggle 1, 0 to 1. Now you see very carefully. This is from 0 to 1. This is from 0 to 1. From earlier I am 0, now I am becoming 1. And this is being fed as a clock to the particular B flip-flop. So 0 to 1 is not a negative edge. 0 to 1 is rather a positive edge. Can you understand? From 0 to 1 transition means it is positive side going, right? Can you understand what I'm saying?
Yes, sir.
From 0 to 1 means from down to up. 0 to 1 means it is 0 to 1. That means it is positive edge. So 0 to 1 transition, that 0 to 1 transition cannot trigger this particular flip-flop because it is 0 to 1 transition. So this flip-flop will be off. If this flip-flop is off, if the clock is not going, output will remain unchanged, 0 to 0. Is it okay?
Yes, sir. Yes.
If 0 to 0, this 0 to 0 is not a transition, it is a level trigger. Level trigger means what? I am 0, I am now also 0, I am now also 0. So it is not moving. So 0 to 0 is a clock for this particular C. So this C is not receiving any transition, negative edge clock. So this C will die off. This C is not going to act. a response. So the output will be definitely, it will be no change. This is the clock 0 to 0 transition. It is not going to make this D flip-flop activate because it is not a negative age trigger. So this also output will not be no change. Now the output is now 1 0 0 0. It is similar to 1 0 0 0. Now I am in this stage. Now let us think that another age, a negative age has come. Clock will keep on going after one time period. Time period of one means from here to here is one time period. From here to here is one time period. After one time period.
Sir, excuse me, sir. That QB is 0 now, so how clock will not trigger in that C?
QB is 0. QB 0 means QB पहले भी 0 है, अभी भी 0 है. So QB is 0. QB is not changing. QB is 0. But it's every flip flop is every flip flop is a negative age trigger. It is not level trigger. All the flip flops can be triggered by a negative age. Negative age means negative going pulse. Negative age. Negative age and 0 and negative age is different. Suppose if I have drawn a waveform like this, this is 0, always 0, 0, 0. This is 1. This is 1, 1, 1, 1, 1, always. This is 0, 0, 0, 0, 0, 0, or every time 0. From 0 to 1, this is positive age. And the 1, it is remain 1, it is remain 1, it remain 1 for quite long time. After 1 to 0, this is another transition. 1 to 0, this is negative age. It is momentary. So now your QB is 0. Your QB is 0. It is fed to the JK flip-flop number C. So this C is a negative age trigger. It is not a level trigger. It is a negative age. If I say it is a level trigger, then it will trigger. Level trigger means it will trigger. It will trigger. This is level. This is level. It will trigger. It is not a level trigger. It is age trigger. It is age trigger. So 0 to 0 means there is no transition. The clock, there is no change in the clock pulse. 0 पहले भी है, अभी भी 0 है. कहाँ change हो रहा? कुछ change नहीं है. It is always 0. So if it is 0, if J and K, if clock is 0, if clock is not given, what do we say in JK flip flop when you analyze?
No sense.
If clock is nothing, forget about the clock. Output will always no change. Can you understand? Can you understand or not?
Yes, sir.
So why I will tell you. Can you understand or not? 0 pehle is 0, now also 0. No, it will not trigger. Here also it will not trigger. Now I am in this. Now let us say that another age is coming. Means another pulse. Pulse will keep on coming now in the clock pulse. In the clock pulse. First time this will come. After that this will come. After that this will come. Negative age. This will come like that. It keeps on coming. This pulse. 1, 2, 3. It keeps on going. So next pulse is coming. Then that means from 1 to 0 transition. Negative age is coming. When another negative age is coming, whether this flip-flop will get alive?
Yes, sir.
Yes, this flip-flop will get alive. Okay, fine. This flip-flop will get alive. And this flip-flop is getting input 1. No need to mention about that. So what will the output down now? What will be output now?
0.
Yes, 0. Good. The output will be 0. Good. The output will be 0 because it is a transition. Earlier it was 1. Now it's become 0. Good. Now you see. Earlier I am having 1, my QA. Now I am having 0. That means 1 to 0. It is similar to a negative age trigger. Though I am not supplying any clock pulse to this B, but the output earlier it was 1. It was already in 1. Suddenly it becomes 0. That means it is a transition from 1 to 0. That means it is similar to an negative age trigger. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
1 to 0 means negative age. From high to low, it is going down. So at that point, what is J? What is K? Obviously, JK is 1, 1. Oh, negative age. Okay, then QB will alive or death?
Alive.
It will become alive. Yes, alive. It become alive. It become active. Then JK to pehle se 1, 1 already hai. No need to mention about that. Then output will toggle करेगा कि नहीं करेगा?
करेगा सर.
तो वो कहाँ क्या आएगा?
1.
1. So 0 to 1. This 0 to 1, is it a negative edge? No, it is a positive edge. 0 से लेके ऊपर 1 तक गया, that means it is a positive going. Can you understand?
Yes, sir.
Yes, sir.
So will
Yes,
this
sir.
particular flip-flop be on or off?
Off.
Off.
Off. It will
Off.
be off because it is a positive edge. It is not a negative edge. From 0 to 1, it is a positive going. 0 से लेके 1. 0 to 1 means going upwards. So it is a positive edge. So it will be off. If it is off, then no change. 0. 0 to 0. No transition in the pulse. This D will never get triggered. So no change. So it will also be 0. So now I have 0, 1, 0, 0. A में 0, 1, yes, 0, 0, yes, correct. ये low है, high है, ये low आ गया. So ये आ गया. Similarly, I will go for another one and I will wind up. Wind up in the sense, I have lots of things to discuss. We have. So now another pulse is coming. Another negative edge is coming. Another negative edge is coming. Okay. Another negative edge is coming. Then will it get alive or not? QA.
Yes, alive.
Alive.
It will become alive. It will get active. It will get active. That means it will toggle. No, output will toggle. होगा ना?
Yes, sir.
So 0 से लेके then it will become 1. 0 to 1. पहले 0 है, अभी 1. Earlier it was 0 to 1. 0 to 1 is not a negative going. It is positive going. It is going from 0 to 1. It is up. That means it is a positive edge trigger. If it is a positive edge trigger, then will this B will be alive or dead?
That's
B will not work. B will not work. B will not work. So what will the output of the B? No change.
1.
No, yes, correct, good. There will be no change. Earlier also 1, now also 1. From 1 to 1, it is not any transition. It cannot be treated as a clock for C. C will be dead. If C is dead, it will be 0, no change. There is no transition, D will be dead. If D is dead, no change. So my output is 1, 1, 0, 0. 1, 1, 0, 0. Can you understand? Like that, you have to analyze, and the same thing will come. So this is the real way of understanding. This is the real way of understanding how the circuit works. The transition, negative edge, as I say, it is a negative edge trigger. I don't say it is level trigger. I never say it is a level trigger. I never say it is a level trigger. I always say that if it is like this, one arrow is coming straight away, arrow like this, then it is compulsory, it's an edge trigger. But this bubble decide that it is a negative edge trigger. If there is no bubble, then it will be a positive edge trigger. And sir, can you explain with the positive edge? Yes, obviously I can explain, but it will be wasted of my time. You can go home and you can see, change it. You trigger over here, every positive edge. The waveform will shift a little bit here. Everything will remain the same. You can make it positive edge also. Since it is given in the book, and I have copied the sham diagram from the book, it is negative edge, so I put it negative edge. It is not compulsory that only negative edge it works. Don't say to your friends. It can be anything. It can be positive edge or negative edge, but not level. Level means in JK flip-flop, there is rest around condition. There is conditions wherein toggle, it will keep on toggling because it's a level trigger. At the end, whether you will get a 1 or 0, controversy is there. Certainty is not there. So you can level trigger, forget about it. So edge trigger, positive edge, no problem you can do. Negative edge, no problem you can do. Can you understand what I'm saying?
Yes, sir.
Positive edge क्या दिक्कत है क्या? Positive edge होने से क्या दिक्कत है? Positive edge means I will take it in a positive way. Positive 1, positive 1, positive 1, positive 1. Same theory, same concept applies. Instead of here 0 to 1, yes, 0 to 1 transition, it will get active. Now we are now we are talking about 1 to 0 transition, it will get active. 1 to 0 transition jab aayega, 1 to 0 is 1 to 0 means high to low, high to low, high to low is negative edge. That is what we are thinking. Now you just think 0 to 1 is positive edge. Earlier it was 0, now it becomes 1. That means it is a transition from low to high. That means it's a positive edge. Similar to positive edge. In that way, you have to think and you can have your own thing. And if I ask you in the exam, positive edge, then you cannot draw this diagram. I can easily catch where the transition takes place in a negative, and you are I'm asking positive edge and you are drawing bubble here, then totally zero. Zero, because you never try to understand in my class. Such type of silly things you are not able to understand. That means you are blur, you are totally blind. So such type of things is very, very important. I will definitely get zero. Okay. Be careful, all these things. So I'm not trying to scare you, but I will definitely give zero if there is any mistake. Ayush? Ayush?
Yes, sir.
Why you are joining now only?
Sir, I was trying to join earlier, but you didn't accept my
No,
request.
earlier means at what time?
Sir, at 2:37.
2:30?
2:37.
2:37. 2:37.
Yes,
So
sir.
7 minutes what you are doing?
So
So
I
you
was
don't
eating,
know.
sir.
So don't you know that the class will start by 2:30?
Sir, I know, but I missed today.
So why you are missing it? I'm a teacher, I don't miss. I'm a teacher,
Sorry,
I don't miss. I try to focus because for you, things get disturbed now. I feel very irritating, such type of things.
sorry, sir. It won't happen
Every
again.
student, many of the students has joined earlier. Why can't you? I have given another 5 minutes also. I have waited for 5 minutes. I didn't start the class exactly at 2:30. I'm also a human being. I understand the situations. There may be some network issues. Suddenly you may not be able to join. So 5 minutes is okay. 5 minutes in before and 5 minutes after. Totally 10 minutes. That is enough for everyone to log in. You people, I don't know why. If this such type of things, if you continue in future, what will be your future? I don't know. So this is your the name is not given here. The name is ripple counter, and this is a 4-bit ripple counter. If it is 4-bit, it is quite obvious you are smart that 4-bit means it can go up to 1111. That means 15. It can go on from 0 to 15. Is it okay? 4-bit means up to 15 you can count 4 numbers of flip-flop. If I have only 3 numbers of flip-flop here, then obviously I can count up to 7. 1 1 1, that means 7. I can count up to 7. So 0 to 7, that means 8. So it will have 8 different states. So this is it a synchronous counter or asynchronous counter? Is this a synchronous counter or asynchronous counter?
Synchronous.
Asynchronous.
Asynchronous counter.
Yes, it is an asynchronous counter. Those students who are saying synchronous, I don't know how he is listening the class. I don't know how he is listening. What is his concept? I don't know. He is from which part of the country or which part of the world. I don't know. I have already told in the beginning also. This is an asynchronous counter. Why it is asynchronous counter?
Because no clock signal given.
The clock signal is there. Clock signal is there. Who said there is no clock signal?
But QB, QC, QD, there will be no clock signal. We are taking clock signal as the output of QA.
Yes, this is not synchronous. Means another way of thinking. What is the meaning of synchronous? Can you explain? Any student, can you give another definition why it is called asynchronous from your own idea? Why it is called asynchronous? Okay, one question I will tell. Are all the flip-flops getting triggered simultaneously at one time? Are all the 4 flip-flops getting alive or dead or alive, whatever, activated simultaneously at one time in this diagram that we have discussed? Are all the flip-flops, 4 flip-flops, get activated simultaneously at one time? No. No, it's obviously no. So the last flip-flop number D, if it wants to get activated or energized or whatever, it will wait for the output of QC. And QC, if it has to activate or deactivate, I don't know. That decides by QB output. So QB also, it waits QA. So QA will trigger QB. QB will trigger QC. QC will trigger QD, the D flip-flop. So one after another, one will be acting as a trigger for the next flip-flop. So it means one after another it goes. It is not simultaneous. It is not simultaneous. But in case of synchronous, this clock will be given here also. It will be given to this one. It will be given to this one. It will be given to a uniform clock will be given to all the flip-flops. Okay, you'll come to know. And now let's see this one. What is this? This is also same thing. Same thing. This is also same thing. I need to explain why this is also a ripple counter. Just now we have discussed. Here you are having 3 numbers of flip-flops. If you are having 3 numbers of flip-flops, you can count up to what number?
8.
8. You should not say 8, 7. You can count up to 7. You can count up to 7, and you should say it has 8 states. 8 states. It will have 8 different states, you should say. But it can count up to 7. Obviously, it can count up to 1, 1, 1, no. So it is 7, not 8. So it can count up to 7, but it'll have 8 different states. 8 different states means what? 0 to 7. It is 8 different states. 0 state, 1 state, 2 is another state, 3 is another state. Likewise, it goes up to 8. And what is the beauty of this? Or the beauty in the sense what? Means like this is a decoder output. See, decoded output. Output will get decoded. What is the meaning of decoded output? Decoded output means here by waveform you are able to know this is 0, 0, 0 means 0. This is 1, 0, this is 1. This is 0, 0, 0, 1, 0, this is 2. 0, 0, 1, 1, this is 3. This is by myself. I am seeing the waveform and I'm able to say this is 0, 1, 2, 3. Here, let us say if an LED glows, if an LED, suppose there is a LED, if a LED and it is grounded, if here is also LED, all LEDs are here, all LEDs. So if this LED glows, then let me say that this is 0. If this LED glows, then let me say that it is 1. This is 2. And if this LED glows, then let me say this is 7. We have all LEDs. So for LEDs to glow, I want 1 here. Obviously, LED is a diode. For LEDs to forward bias 1, and this should be grounded 0. So P-type, N-type. So if it is high, so it will forward bias, it will glow. Is it okay or not? Can you understand up to here?
Yes.
What I'm saying? So now the question is how to make this particular LED glow when it is 0, 0, 0. Obviously, when 0, 0, 0 earlier we already know when in the first clock pulse 0, 0, 0 means QA will become 0, QB will become 0, QC will become 0. Then QA bar will become 1, QB bar will be 1 because this will be complement, QC bar will become 1. Then let me connect QA bar, QB bar, QC bar 1, 1, 1 to an AND gate, and it will give a high signal because QA bar is 1, QB bar is 1, QC bar is 1. That is why QA bar, QB bar, QC bar is given 1, 1, 1. This LED will become glow. This LED will glow. Rest of the LED will not glow, and this means 0. Or then that means I can simply say, oh, count ho gaya, or 0, 0 se shuru ho gaya, 0 ho gaya. What about the remaining? All the remaining will be off during that time. All the remaining will be off. If you want to analyze, you analyze it. See, these are AND gate. All the input should be 1, 1, 1. Ye kaha 1, 1 hoga. You just see, it is connected where? See, this one, this where? This is connected to. See, it is coming here. It is coming here. It is connected to 0. So ये तो 0 होगा ही होगा. And then and then this one, ये देखो, it is connected here. This is connected here. This is connected. ये वाला, it is connected here. It's coming here. It's going here. Going here. Going here, and it is connected here. So it will be 0. Can you understand what I'm saying? You can analyze it, and everything will be 0. Then let's say this is the third one, 3, 1, 3. 3 is Q3. Clock, no, first clock, we know, we already analyzed what should be the output. We have already analyzed, no need to analyze again and again. We have already analyzed. So 3 means it will be like that. 3 means what? Yeah, LSB, this is LSB, this is MSB. 3 means 0, 0, 1, 1. Can you understand? 3 means 0, 1, 1 hoga na. Is correct? What I'm saying?
Yes, sir.
Because this is your MSB. So 0, 1, 1 is 3. And then this will become 0 because it will be ulta, opposite. This will become 0 because they are complement. This will become 1. Then you just see how this is connected. QC bar 1. So QC bar will definitely be there. So QC bar will definitely be there. And QB will be definitely there. QB will definitely be there. QA also will definitely be there because they are 1. Yes, because I want all the output which is 1, 1, 1. And there you just connect. That will give your output 3. Is it difficult? It is not difficult. Is it okay?
Yes, sir.
Yes, sir.
Science.
Jaha 1 hai, wherever there is 1, 1, 1, there only you'll connect. And I will just give the name QC bar. Yeah, QC bar will become 1. So QC bar. So Q3 is a QC bar, QB, QA, like that. So it is easy. It is not a big issue. No problem. Is it okay?
Yes, sir.
Yes, sir.
If you have any
Yes,
problem, you should ask at any time. Okay. Now let's go to next one. What is this? Ye kya hai ye? Ye kya hai? This is important. This is important. Whatever we have discussed, we have 3 numbers of flip-flop. Oh, we have 3 numbers of flip-flop. Then we can go up to count up to 8, 7. That means we'll have 8 number of steps. How do you know? 2 to the power 3 is 8. We have 4 numbers of flip-flop. If you have 4 numbers of flip-flop, then I can go counting up to 15, 0 to 15. How do you know? 2 to the 4 is 16, so 0 to 15 is 16. If we have 2 numbers of flip-flop, I can count up to 4. That means 0 to 3. 0 to 3 is 4. 0, 1 to 3 is 4. Okay, we know this thing. Very easy. This type of questions should not be asked. Even if it is asked, we should be able to answer it very fast. These are nothing. This should not be taught to the student. Student by himself, he or she has to learn those things. Anyway, now this is 3 flip-flops. So it can count up to 7, 0 to 8. It will have 8 states. But I want it to count up to what? Mod 6. Mod 6 means what? Mod 6, what is the meaning of Mod 6? In the beginning of the class, I said what is mod counter. Mod 6 means what? Mod 6 का मतलब क्या है? What is the meaning of Mod 6? Fast.
Multi-mode.
Huh? Mod 6 का मतलब क्या है? जल्दी बताओ ना भाई.
First 3 flip-flops are required.
Pardon?
Five.
Mod 6. What is the meaning of Mod 6? Modulus counter. I was telling, I have already explained this. What is a modulus counter? It can be classified as single or mode and multi-mode. Single mode means up, down, up counter or down counter. Multi-mode means it can count up, it can count down also. Modulus counter, mod 6, mod 10. What does it mean? Mod 6 means what does it mean? Bolo na ba? Why? I don't know.
Don't know, sir.
That means we have to take 3 flip-flops.
No. 3 flip-flops ke lena dena nahi. What is the meaning of mod 6? When I say it's a mod 6 counter, mod 6 triple counter, what does it mean? ये diagram दिमाग में आने की जरूरत नहीं है. The only thing is that I'm asking what is the meaning of mod 6?
Connecting the 3 flip-flop to one another.
No. What is the meaning of mod 6? I have already explained. That is the thing. You people never listen. Just now in the class, in the beginning of the class, I have explained everything. What is modulo counter? What is synchronous? What is asynchronous? What is single mode? What is multi-mode? What is modulo counter? Modulus. Mod 6 means what? Mod 10 means what? What do you mean by mod 6? If you are not responding, whether right or wrong, if people are not responding, I will give all these things. I will upload in the this thing. I will upload in the Google Class. You did by yourself, okay? So we wind up if you are not responding. I'll give all these things. I will not teach you because I don't want to teach because you people are not responding. You people are not understanding that you people are not listening. I have already explained the things which I have already explained in today's class. If you are not able to recall it, then what is the point of wasting my time? I'm wasting my time. I'm talking to someone who are not listening to my class. So it's better you are not interested in my class. I will give all these things in the Google Classroom. You read by yourself. You are smart enough, and then that will be the way I should treat if you're not responding.
Sir, we are late, so I could not attend that part.
No. What about the remaining student? Why they are not able to explain? Why remaining students are not able to explain?
Sir, Mod-6 counter will require 3 flip flops and it will count from 000 to 100. The rest of the states are invalid, sir.
000 to 100.
Yes, sir. 000 to 101.
101. So.
And the rest of the invalid, sir.
So Mod-6, when somebody says Mod-6, it can be ripple counter or it can be synchronous. It can be synchronous counter. It can be asynchronous counter. Doesn't matter. If it is, if they say Mod-6 counter, that means what? I should design a counter which is having 6 different states. It should have 6 different states. It is meaning it should have 6 different states. The states can be A, B, C, D, E, F. This A I can represent by 000. B I can represent by 001. C I can represent by 010. D I can represent by 011. E I can represent it by 100. F I can represent by 101. So it will have 6 states. It will have 6 states. If it is going to have 6 states, then how many flip-flops will be required? That is the questions that you have to understand. And that is the answer you have to find by yourself. It is very easy. If I have to have 6 different states, then how many flip-flops is required? That is not something which I should taught. And that is the reason why there is 3 numbers of flip-flop. In the questions, I can ask you 3, Mod 3, ripple counter. Here it is Mod 6. I can ask you Mod 3, Mod 4, Mod 7, Mod 8, Mod 10, Mod 16, Mod 12, Mod 13, anything I can ask. How many flip-flops will be required? That is your decision. Now, you just see, this is just the counter which we have. J and K is connected to VCC. Earlier VCC was up, now it is down. No problem, it is connected to VCC. J is 1 always, K is 1. J is always 1, K is 1. J is always 1, K is 1. No doubt, no problem. Now, it is telling up to Mod 6. But if there is 3 numbers of flip-flop, I have to count from 0 to 7. By default, it will count from 0 to 7 because we are having 3 numbers of flip-flop. But they are telling 0 to 7 means what? 8 states. 8 states we have. But it is telling to count up to 6 states. 6 states means what? 0, say like 0, 1, 2, 3, 4, up to 5. Then don't go 6. After 5, come to 0, 1, 2, 3, 4 to 5. Don't go to 6. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Like that, it should count. You have to design a circuit so that it can count from 0 to 5. 0 to 5. Is it okay?
Okay, yes, sir.
Now, how to do? Very simple. You just draw the waveform. How to draw the waveform? Hey, this is just a ripple counter. Yes. So this is ACE trigger. We know it. Just now we have discussed. Now this will trigger. So this flip-flop will trigger this one. So I will trigger it here, toggle. And here again, toggle. Here again, toggle. No, this you know very well. And this will trigger another one. This will be acting as trigger pulse. It will trigger another one. Yes. It is getting 0, now 1. And then trigger. And then now it goes. And now it comes up. Can you understand? And it tries to go like this, no? Can you understand? But they are not showing. But it should go like this. I will do it like this. Can you understand what I'm saying? Because it is triggering. So earlier it was low, now it should go high. Is it okay?
Yes, sir.
Yes, sir.
Okay. Don't bother about the waveform that they have given. Now, this is going to be triggered, negative ACE. So if negative edge means it will go, oh, transition trigger, and it should go like this. It should go like this up. Is it okay? Is it okay or not? Up to here.
Yes, sir.
Now,
Yes,
just see here. This is 0, low. This is 0. This is 0. 0, 0, 0 is 0. Now, from this to this one clock pulse, another clock pulse is from here to here, another clock pulse is from here to here, that you know very well. Here it is 1, see high, now it is 0, low, 0, low. So 0, 0, 1 means it is 1. Now this is 0, low, this is high, 1, this is low. So 0, 1, 0 is 2. Now this is high, this region is high, so this is 1. This is also high, this is 1. This is low, so this is nothing but 3. And now this is low, 0, this is 0, and this is high, 1, so this is nothing but 4. And now this is high, well, 1, and low, 0, this is high, this portion is high, no? This is 1, so 1, 0, 1 is nothing but 5. Up to here, you understood? One more.
Yes, sir.
Sorry. Up
Yes,
to here,
sir.
you understood. So up to here, you understood. So whatever things may be given in the question, you just draw the full waveform, and then you do it. Full waveform, you do it. Full waveform up to a 6, 5, 6, 7, 8, up to full you draw it. Then the question, what does it say? It says we should have only 6. Oh, then from 0 to 5 only it is asking for. Oh, just after 5, you just see, after 5, I want to make it 0. I want to make it 0 after 5. Is it 0? Oh, luckily this fellow is 0. This fellow is 0. See? This fellow is 0. Luckily, this flip-flop number QA, flip-flop is 0. QA, flip-flop number A is 0. It's coming 0, down, 0. After 5. 5 means up to here, okay? At this point. Can you understand? I'm drawing a line here. Can you understand? This is 0. This is 1. This is 2. Third step. Fourth step. Fifth step. So, first step, second, third, fourth, fifth, six different steps. So mod 6 in terms of number 0, 1, 2, 3, 4, 5. Is it okay? So the transition you should know. This is the margin. After this, you should get output 0, 0, 0. All the flip flops. Is it okay? What I'm saying? Your aim, your desire. What do you want? I want all my flip flops to turn to 0, 0, 0. Is it doing like that? No. But luckily, this fellow, this flip flop is 0. But this flip flop, see, it is 1. It is 1. This flip flop is 1. And again, this flip flop is also 1. Oh, these two flip flops, QB and QC, is going to create problem. But I want it to be 0. Then what I should do? Then this QB is 1 at this point. See, it is 1 during this portion. 1, it is 1. QC is also 1. After this time, it is getting 1. So QC is also 1. Then you do one thing. You arrange one circuit, NAND get NAND. QB was 1. QC also 1. 1 and 1. Output is 0. So if the output is 0, then you give it to a flip-flop. You just arrange clear bar. Clear bar, clear bar, clear bar. That means what? Bar. That means active low. Bar means active low. Active low means it will become active when I get a low signal. Are you getting a low signal? Yes. QB is 1, QC is 1. I'm getting a low signal. Yes. Then this will become clear. The output will become 0. It is also clear because it is connected to everyone. Output will become 0. Output will become 0. Now, you just see output will become 0. Now you see the original waveform that they have given. You just see the original waveform that they have given. Can you understand or not? I don't know. I think you should be able to understand. This is 0 already. But see, it was earlier, it was 1. Pehle 1 tha. Because of that 1, QB, because of this QB1, because of QB1, 1. Pele 1 tha na. So because of QB 1 and QC also 1, it should be 1, no? It should be 1. Can you understand earlier? It should be 1. As
Yes,
per
sir.
the explanation, it should be 1. Q and QB is 1. Q and QB is 1. After Q and QB 1, student, everything becomes 0. That means this also should become 0. This also should become 0. So Q and QB become 1. Just Q and QB become 1 for a few seconds. Just Q and QB start to become 1. QA and QB just they start to become 1. After that, it is signal is sent to the clear and all the flip-flops get clear. That means after a very small time, it becomes 0 again. It becomes 0 again. So that is why there is a little up. There is a little up because little up is important. Because of this little up here, I don't know whether you understood or not. There is a little up portion is okay. Can you understand? See, little up portion is there. QB is 1. QC is also 1 for little moment of time. If because of that, it gets 0. This is NAND get, and every flip-flop get clear. So now, after this small time, you get 0 as it is 0, 0. You get 0 here. You get 0 here. So now it has become 0. And in the next clock pulse, it will again, but in the next clock pulse, it will start again counting from 0 to ho gaya, then 1, 2, 3, 4, 5, then 0, 1, 2, 3, 4, 5, it will go on counting. Can you understand? Any doubt? Can you understand what I'm saying?
Not clear, sir. No, sir. Function of n naught is not that clear, sir.
I have to count up to 5. I have to count up to 5. Up to 5, I have to count. Yes, it is coming 1. It is coming 0. This portion is 0. This portion is 1. This portion is 0. And this portion is 1. So it is 5, it is coming. After 5, I want to make it 0. Why? Because I am having a Mod-6 counter. Mod-6 means it should count from 0 to 5 only. After 5, I want 0. Is 0 coming? No. 0 is coming here. Okay. Is 0 coming here? No, 0 was not coming. Is 0 coming here? No, 0 was not coming. It was high. It was high. It was high earlier. 0 was not coming. Instead, it was like 0, 1, 1. It was 0, 1, 1. It was not 0, 0, 0. It was 0, 1, 1, obviously. So 1, 1, I have to make it 0. This 1, 1, I have to make it 0. Or this 1, 1, you have to make it 0. Then what is this 1? This is Q of B. And this is Q of C. QB and QC is becoming 1. Then in this NAND gap, you just design a NAND gap, and QB and QC, you just put it, because these two are 1. Whichever is 1, you have to just put it. And you have to clear it, all the things. Finish. Then by default, the QB is 1, QC is also 1 at the time. So 1, 1, go here, output is 0. Every flip-flop will get clear. Then after very short period of time, it will become 0. The waveform will, now earlier the waveform was high. It will high for some time and it will become 0 like this. It will high. Earlier it was high like this. It will become high and then after for some time it will become 0. For number, now this one also, it will be high. After for some time it will become 0. Earlier it should be high, but it will be high and it will become 0. It will not remain high because it is already clear. So the output, this will be clear, this will be clear. So everything will become 0, 0, 0. Then in the next clock pulse, it will become 1. In the next clock pulse, it will start again counting from 1, 2, 3, 4, 5 like that. I am forcing it to make it. Normally it will be 6. After 5 it will be 6, and it will definitely be 6. That 6 I don't want to get that 6. Instead of that 6, I want it to force to 0. I want all the outputs to be 0. Which one is not getting the output 0? QB and QC is not responding. QB and QC is not getting 0. If I happen to get QB and QC 0, then I got all the output to be 0. Then QB and QC, which is not getting 0, which is not giving the output 0, then you connect to the NAND gap. That is the logic. Now I am asking, Now I'm asking mod 3. How will you do? In this, I'm asking mod 3. The diagram, same diagram, mod 3. Which one will, which input will be given to
Excuse me,
this
sir.
particular NAND gate? Mod 3 means 0 to 4. Mod
Excuse
3
me,
means it will have only 3 steps, 0, 1, 2. Mod 3. If I ask mod 3, then what to do? Just think and then tell me. Which input
Excuse
will
me,
be
sir.
given to the NAND gate?
Excuse me, sir.
Yeah.
Before answering that one, I have one doubt, sir. Means that this AND gate will work only after state 3. How is that possible?
Pardon?
This AND gate will work only after this one. That it will work after 6 state. After 5 only.
What you are saying?
AND gate. That
Tell.
in that AND gate,
NAND
no,
gate,
sir.
you said NAND gate. You don't know what is the difference between AND gate and NAND gate.
No,
This
sir.
is NAND
NAND
gate,
gate.
not AND gate.
That NAND gate, sir. Yes. The NAND gate.
Ah.
How it will work only after this 5.
What is the input of this NAND gate?
1
What are the
1
input of this NAND gate?
1 1.
What is the input in this NAND gate?
QB/QC.
1 1.
Yes, QB/QC. QB/QC. QB also becoming 1, QB also becoming 1. Then only NAND gate will operate. It will give output 0. Is it right or wrong?
Yes, sir.
When only QB and QC is given to the NAND gate, and only when QB and QC become 1 1, all the devices, all the flip-flops will get clear. Is it right or wrong?
Yes, sir.
Yes, sir.
Yes. Yes, it is right. Then use your brain. You have a brain, okay? You have a hat God has given to you. You use that one and you see in which point of time, in which trigger impulse, in which pulse, in which place, I get QB is equal to 1, QC is equal to 1. Where do you get QB1, QC1? Yeah. Can you get QB, QC1 here? No. Can you get QB, QC1 here? No. Are you getting QB, QC1 here? No. Are you getting QB, QC1 here? No. One is going down, one is going up, one is down, one is up. No. Both are not one. Are you getting QB, QC1 here? Yes. 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 Normally it should be like this. Normally it should be like this. Can you understand what I'm saying? So QB, QC becoming 1 only at this point of time. Why? Because I have already decided from the waveform that it should be QB, it should be QC. Why? Because at this point of time only QB and QC is becoming 1. That's why I'm choosing QB and QC only, not QA. Based on what mod? Mod 6 means this line. Mod 6, I have to count up to mod 6, man. I know that this line, up to this line, I have to count. At this line, it has worked successfully. 5 is counted. Yes, this is 1. Okay, this is 0. This is 1. Yes, 5 is successfully counted. After 5, it is counting 6. It is counting 6. Really, after 5, it is counting 6. So let me show you. After 5, it is counting 6. They have ready-made waveform. That is why you should know the basic first. After 5, it will be like this. That is the, after 5, say it will be like this. This is another trigger. So after 5, it will be 1, and it will go. It will go. It will go. It will go. It will not come back to 0 because this is this trigger. When it becomes here, then only it goes like this. And this pulse will trigger this one. So this will become high. This will, because this is QB 1 2 1 2, and this is positive edge. So it will remain. This is positive edge. This is positive edge. So it will not trigger. So it will high. This negative edge, then it will become low like this. So this is the thing. So this is what this is 0. This is 1 high. This is 1 high. So the 1 1 0. This is 6. So in this time period, it is 6 is coming. And what about this clock pulse will go like this also? So this is positive and this is negative edge. And here it is 1. Here also 1. Here also 1. This is 7. This is the pattern. This pattern I have to break. This 6 and 7 I have to break it. Instead of 6, I have to get 0. This is already 0. Who is creating problem? This one is creating problem. This one is creating problem. Who is this fellow? This is QB and QC. Okay, take that QB and QC and force them into this NAND gate and make the all the flip-flop to clear. Yes, it is done. Now, sorry, it is clear. But when I say it is clear, but still speaking, somebody asks whether QB and QC, whether the state 0. QB sometimes for a moment of time 1. QC for a small moment of time 1. That means the what to say, appear in your circuit. Yes, it never appears. Don't say that it never appears. It appears, this 6 appears in very short period of time. It appears. After that, 0. So it appears, since it appears for a very short period of time, we neglect it. Can you understand? You can see from the waveform, it appears for a very short period of time. It appears for a very short period of time. You just see, you just draw a line here. You just draw a line here. It appears for a very short period of time. You cannot say that 6 doesn't appear. We don't want this 6 to appear. We don't want this 6 to appear for sure. We don't want this 6 to appear. It is true that we don't want this 6 to appear, but it should appear. Otherwise, we cannot design. You just see, this is the timing. This is the time. See, for a very small time here, QB is 1. QC is also 1. Normally it should be 1. But since the output is fed to NAND gate, intentionally I'm designing this circuit. Since the output is fed to NAND gate, since it is 1, 1, as soon as it becomes 1, it becomes 1. Suddenly, the flip-flop will all get 0, 0, 0 clear. As soon as QB and QC 1. So as soon as QB and QC becomes try to get 1, suddenly all the flip-flop will get reset or clear. Now I got 0, 0, 0 in all the flip-flop. So QA, QB, and QC all 0, 0, 0. So if somebody asks whether the state 6 does not appear, no, it appears, but it appears for a very short period of time. Can you understand or not what I'm saying?
Yes, sir.
Yes, sir.
Now, let me see whether you have understood or not. Now I say mod 3. Mod 3. For mod 3, what input I have to give to this particular NAND gate?
The QA, QB.
For mod, let me I was telling mod 4 or mod 3. Okay, mod 3. I'll fix mod 3. For mod 3, I will give you the hint. For mod 3 means what? Mod 3 means 3 states. 3 states means 0, 1, 2. It should count to 0, 1, 2. Here to here is one time period. It counts 0, 0, 0. Okay. This is one time period. 0 and then uske baad 1. So this is 1, 1 or up 0, 0. This is 0. This is 1. Okay, good. 2, 2, 2, 2, 2, 2, 2, 2, 2. Yeah, again. Yeah. This is 2. 2 means 0, 1, 0. This is 2. Now, after this 2, you just see this is a normal flow. This is a normally it should flow like this, it should go like this. But I want intentionally this. After 2, I want this to be 0. That means I want to force this particular thing to get down to 0. This I want to get down to 0. This is already 0. Then what should be the input to this particular NAND gate?
QA, QB.
Exactly, QA, QB. Who is telling?
Sir, Nilutpal Fukan.
Good. QA, QB, exactly. Because this is not obeying. This is not obeying. This is not obeying. These are 2 are high. This 2 high, you fed it there. Finish. Now, same question again. Mod 0, 1, 2, 3, 4. Mod 4. If I want to count up to mod 4, what should be the input? Nilu, mod 4. Mod 4 means it should come from 0, 1, 2, 3. If I have
Sir, QA, QC. QA, QC.
Pardon? Mod 4?
QA, QC.
Be careful.
Oh, no,
See
no,
careful
sorry.
in the answer. See carefully and answer. Mod 4 means it should come from 0, 1, 2, 3. So 0, 1, 2, 3. Oh yeah, 3, and this is 3.
Yes,
This
sir.
is 3, 0, 1, 2, 3. And now it should become 0. After 3, it should become 0. Mod 3 means 0, 1, 2, 3. Then 0, 1, 2, 3. This is mod 4. I'm asking mod 4. If it is going to be mod 4, that means 0, 1, 2, 3 is 4 step. After that, 0, 1, 2, 3, 0, 1, 2, 3, like that it should count. So 0, 1, 2, 3, up to here it is counting. Now I want to make this. Actually, it should be 4, but I want to make it 0. So what should be the input to my NAND gate?
Both the input should be QC.
There are 2 zeros,
QC.
sir. So no
QC.
possibility.
QC. So whoever is saying QC is good, his answer is correct. Then how will I connect? The NAND gate is like this. How will I connect QC?
In both, you
Both
connect
to both
QC.
inputs.
Yes,
Connect both.
Okay. Yeah, you are telling both also no problem. QC, I can connect QC and QC also no problem. But in
Sir,
the
can
exam,
you connect not get?
in the exam, you can connect this thing, QC like this. QC. Instead of NAND gate, you can connect NOT gate also. No problem. Good. That is
Yes,
also
sir.
a good idea. No problem. But why I use NAND gate? Because NAND gate will be common for all the design. It will be common because that will be a common concept. Now you are saying, can you use NOT gate, sir? Yes, good. You can use NOT gate. You can use NOT gate because you know very well that QC is 1, QC is equal to 1. Then I want 0 here. So you can use a NOT gate for this particular design. You can use NOT gate. Good. I will not give. It is not like I will give 0 for that. It's good. I have to give full mark because it is satisfying. You are doing your own. It is correct. As a teacher, I should not say that whatever I have taught, you should be doing like that. No. As a teacher, if anyone is doing anything differently, I should look into it and I should give marks according to it. So it is correct. If you use not get also is correct. But this not get will not be always true for different case. So for the best thing to remember is just a NAND gap and this thing. So it will always satisfy. That's why in the book also, and I also suggest you people to use NAND gap. But if you are smart enough, sometimes based on the question, you can use not get. Sometimes based on the question, you can use NAND get or NOR get or whatever get you want to use. You use it. I will analyze it and I will see to it. And accordingly, I will give the marks. Full mark. If it is satisfied, full mark. If the circuit is working, full mark. Okay. The best thing is try using NAND gate. It will be helpful so that you can avoid confusion. User C. Let the teacher ask anything, whatever mod. You just see, you just draw a line up to here. I have to count, and which one is not obeying? Oh, I have to make it 0. Or here it is. Which one is not obeying? This one is not obeying. This one is not obeying. This is high. This one is also not obeying. QA and QC is not obeying. Then QA and QC, I will put it here. Very simple. Very, very simple. Don't think that it is very difficult. If this type of question comes in the exam, it is very simple. And is this a synchronous counter? No, it is not a synchronous counter. How do you say it is not a synchronous counter? Output is fed as an input clock to the other. Output is fed as an input clock to the other. How can it be a synchronous counter? So it is an asynchronous counter. So in the question, I will be asking like design Mod-6 asynchronous counter using ZK flip-flop. Then you have to do the same thing here. Design mod 11 asynchronous counter. Mod 11 asynchronous counter or asynchronous up counter. Up counter means 0, 1, 2, 3, 4 up to 11. Then 3 flip-flop will it be okay? No, I should use 4 number of flip-flop. That way you have to think, is it okay?
Yes, sir.
Yes, sir.
Means like, see, as a student, I'm not telling that, means like, I'm not telling that I'm very smart, I'm very good. I was also a student, I was of your level. I am a teacher now, I read things in advance, I read for many books. That's why I'm able to tell you the truth based on my experience. And whatever I'm saying, it is not from my own. I am not the scientist. Only from the book I'm getting the information. I am not designing all these things. Book is giving me the information, I am just passing it to you. So as a student, if you know this thoroughly, Then in exam, you may say, okay, synchronous ka koi bhi question puchne do sir ko. Let him ask any questions. I am ready. That level you should know for each and every subject. Then I can guarantee you, you will become a very good scientist. You can become a scientist. So both of them, it's quite sure because you are knowing better than the teacher. Then at that level, then when you attain your A's after the completion of BTech or MTech or whatever, you will be outstanding because your level of understanding is very high. So you always try to know the things rather than simply mugging up. Let the teacher ask any question. I don't bother. In numerical control system or circuit analysis and all these things, mesh analysis, nodal analysis, current law, resource voltage law, whatever, Thevenin's, Norton's, superposition, reciprocity theorem, whatever. Let him ask any questions, any circuit. Let him give. I will do it. At that level, you should know. But it is not that easy. But if you know at that level, you will be somewhere where people don't, it's like people find it very difficult to get. You'll be on top of the world. Okay, so another 5 to 10 minutes I will take because I have lots of things to cover. So this is about asynchronous. Now see, this is what. Don't think that everything's are very difficult. Take it very lightly. This is very simple. See, earlier I was taking the output from here, QA select. I was taking from QA and to the clock, QB and to the clock, and output also QB. That was what I was doing earlier. See, in all the diagram, see the beginning, see, QA is an output, and from QA is a clock. QB is the output, and QB, I fed it as a clock. Like that. But now it's just reversed. See, from QA bar it is taking, but the output is from QA, output from QB, output from QC, most significant bit, least significant bit, same thing, same concept. But the only thing is that this triggering is being done from the bottom. From the bottom, there is Q bar, from Q bar. Then this type of counter will be a down counter. Down counter. So if I ask in the exam, down counter, very simple, it will count down, just connect it ulta. From earlier you are connecting it like this and you are giving it here. Now this is not connecting, and from the complemented output, Q bar, you are giving the connection to the clock. So this is again asynchronous. Yes, it is obviously asynchronous because one flip-flop is getting trigger pulse from the other flip-flop output. So it is obviously asynchronous. Mod-8, yes, it is Mod-8 because 3 flip-flop can count up to 0 to 7. 0 to 7, you will have a different state. So Mod-8, very good, but it will be a down counter. That means starting from 1 1 1. Let's say earlier it is 0 0 0. Then in the first clock pulse, it will become 1 1 1. You can analyze it very easily. You can analyze it. Okay, so I will not analyze. It will take time. With your understanding, you analyze it. It is a down counter. It will be a down counter. Can you understand? It will down counter. If you have any problem, you ask me anytime. I will not explain this one. It is very similar to your up counter. You can analyze at home. It's a down one. It is actually going to count from down. Earlier, let's say it is QA 0, QB 0, QC 0. Now in the next, shall we try once? Shall we try once? Or will you do it at home? Any response? Shall we try once or shall we do it at home?
Try once.
Try once.
Okay. So let's say this is 0. Let's say this is 0. Let's say this is 0. Because this is 0, this is 0, earlier this is 0. When a negative AS clock pulse comes, clock pulse going to the QA first. So negative AS clock pulse is going here. If negative AS clock pulse is going, that means negative trigger, negative AS trigger. All are negative AS trigger. So now, since it's connected to VCC, J1, K1, J1, K1, J1, K1, the output always double. Okay, now clock is given and it is also negative AS. Since it is negative AS, all negative AS, negative AS, negative AS, all are negative AS trigger. Negative AS trigger. Okay, fine. So it is negative AS trigger. So negative AS is coming, triggering. So output will become, now the output will become, I'll write 1. The output will toggle करेगा ना?
Yes, sir.
So earlier, let us. So earlier, what about this one? Earlier, what will be here? Earlier 1. This one 1. This one output is 1. Can you understand?
Yes,
In the
sir.
beginning, because ये 0 होने से तो ये 1 होगा. If it is 0, this will be 1. If it is 0, this will be 1 because this is complement. Okay, now let us give a pulse. Clock pulse has come. Let us think and let us see how, when the clock pulse has arrived, this will become alive and it will trigger. Trigger matlab it will get trigger and it will toggle the output. So the output 0 will become 1 and this 1 will become 0. This 1 will become 0. Can you understand? This 1 will become 0. Earlier it was 0, it will become 1, then it's toggle. Earlier it was 1, it will become 0. Problem hai kya? Any problem?
No, sir.
But see, the clock is given over here. And this is earlier it was 1. And now it is getting 0. So 1 to 0. That means 1 to 0. Is there any transition? Yes. Is it a negative or positive edge? It is negative edge. 1 to 0 means high to low. It is a negative edge. If it is a negative edge, it will also get alive, activated. And since J and K is 1, 1, it will toggle. Output will toggle. So output will become 1 and it will become 0. Earlier it was 1. Now it is getting 0. Earlier it was 1. Now it is getting 0. It is high to low. Again, this also will again trigger. J and K is 1, 1. Output will toggle. So this become 1. This become 0. So now, what is my output now? Earlier my output was 0, 0, 0. What is my output now? My output is nothing but QB, QC, QB, and QA. What is at present? At present it is 1. At present it is 1. At present it is 1. So now it is 1, 1, 1. Is it okay?
Yes, sir.
Yes, sir.
Now, anything? Now, another step. One more step I will do for you. One more step. Now let's say another clock pulse has come. Another negative clock pulse has come. And because of that, it becomes active. If it is active, it will toggle. Now green tha, earlier it was green 1, it will become 0. 0 aa jayega. Then 0 will become 1. 0 to 1, is it a clock? 0 to 1, it is a positive edge. It will not work. Output remain as it is 1. Remain as it is 0. 0 to 0 is going to affect? No. Output remains same, 1. Output remains same, 0. So what is my output? Blue 1. What is my output? Blue 1 at present. What is my output? Blue 1 at present. QA is 0. Yes, QA is 0. QB is blue 1. QB is blue 1. High. QC is also blue 1. QC also blue 1. High. Can you understand? It is matching, right?
Yes, sir.
So like that, it should follow. So that kind of understanding you should have. So this is what I mean to say is that from here, what is the take away? What you should take away from this particular class or understanding is that you can have up count. You can have down count. The only thing is that for up count, you have to take from the QN output. For down count, you have to take output from QN bar as a clock. As a clock. Is it what to be understood? Right? Correct, no? Up count, for up count, output is taken from QN and it is fed as a clock to the next flip flop. In case of down count, countdown 10, 9, 8, then you are taking the output of QN bar as a clock. Is it okay?
Yes, sir.
Okay. And the final output, whatever the final output you are taking, it is from QN only. QN only means QN, QC, QB, QA, whatever. Output is no change. Output is always from the Q, not from the Q bar. That also you keep in mind. Output, the final output is always from Q, not from Qn or Q bar, not from Q bar. Down count, for down count, the clock should be given from Qn bar or Q bar, and also the output should be taken from Qn bar or Q bar. Then concept is wrong. Output, no, you should not change the output. Output will be always Q, not Q bar. But for up down counter, clock pulse, for up, output will be from QA, for down from QA bar. That's all. But always output will be from Q. Can you remember? Please remember. Is it okay?
Yes, sir.
Yes, sir.
Okay, now let us see this one. Don't think that this is very difficult. Don't think that this is very difficult. This is asynchronous. Asynchronous means what? Asynchronous means what? See, clock only given here. Clock is given only here. Is negative is, negative is, negative is. Clock is given only in the first one, and we don't have anything at the consecutive flip-flops. This is 4 numbers of flip-flop, so it can have 16 states. I can go from 0 to 15 count. That is how we are counting. 0 to 15. And it will come 0 again back. 0 to 15, 0 to 15 like that. It can count down from 15 to 0, and then 15 to 0 like that. Count up and count down. So it's very easy, count up and count down. What is easy? Because I know for count up, I know that the output of the clock for the next flip-flop should be taken from Qn. And from down, I know that the output should be taken for the clock, should be taken from Qn bar. This same concept I'm going to use here. If I'm going to count up, this terminal uses put it 1. That means what? You are taking output from here. Is it okay? Because in an AND gate, if one of the input is 1, the other output is QA is here. If it is QA, QA will come here, AND gate. Can you understand what I'm saying? In AND gate, if one of the input is 1, this A will be here available. A means this will be A. Let's say 0, answer will be 0. Let's say 1, answer will be 1. Can you understand what I'm saying?
Yes, sir.
So it is very simple. This AND gate, when count, you are going to count up. For count up, the output or the clock pulse that you are going to give in this flip-flop, the clock pulse that you are going to give in this flip-flop should come from QA. Is it correct? What I'm saying? For count up, it should be like this. No, it should be connected like this. Is it okay?
Yes, sir.
So is it doing like that? Yes, it is doing, because I am keeping count up. This one is always fixed to 1. That means this output of this AND gate is always Q of A, whatever QA is coming here, and that QA is going to an OR gate, and it is always going here. What about What about this QA bar will not come, sir? Yes, it will never come. Why? This is 0 during the time. If it is 0 in AND gate, you know, if one of the input is 0, always it will be 0. So always this will be 0. So we will never consider this. So in the up counter, while trying to count up, I will be, so since this is very dirty, I will be taking the output from this, while from up counter. That is why this control signal should be always 1. So this is for up. If it is 1, it is for up, and this control signal should be 0. If it is for down counter, then this control signal should be 1. Here, this control signal should be 1, and the control signal over here should be 0. Then this output here will pass over here. Can you understand what I'm saying?
Yes, sir.
Yes, sir.
Is it difficult? This is not difficult, because the concept, this is the concept. This is the concept. For up, I have to see. For up, I have to, I don't know whether you have understood or not. It is very simple. There is nothing to discuss much on this. It's very simple. I will do with different colors, and I will wind up. I cannot take too much class because it's very boring if I take too much, but I have lots of things to cover. Anyway, see. For up, for up counter, this should be okay. Down counter. For down counter, I will say down counter, down count 15, 14, 13, 11, 13, 12, 11, 10 like that. This should be 0, and this will be 1. If it is 1, it is countdown. Which particular AND gate will operate? This AND gate will operate. This AND gate will operate. This AND gate will operate. If this AND gate is operated, then what is going here? QA bar is going. QB bar is going. QC bar is going. Obviously, then it is a down counter. Good. Then for up counter, reverse is the case. For up counter now, this will be 1. This will be 1. This will be 0. So if it is 0, this will not work. This will not work. This will not work. This will work. QA will come here. This will work. QB will go here. This will work. QC will go here. So it will perform up counter. Is it okay?
Yes, sir.
Now, see, I will not. I have taken. You may be boring. I will not take this one. Okay, but I will simply ask: Is it a synchronous counter or asynchronous counter? Simply, I'm asking, and I will wind up. Is it a synchronous counter or asynchronous counter?
Synchronous.
Why?
The clock is given to
Yes,
everyone.
clock. See, clock is given here. Clock is given here. Clock is given here. Clock is given here. All the clocks are given. And the trick in the sense, in the asynchronous counter, J, K always 1, always 1. J and K is always 1, 1. Here, J, K is 1 only over here. J, K is not 1. J, K is not 1 here. It depends on the output. J and K, it can be 1, it can be 0. It depends on the output. J and K depends on the output. So this is not asynchronous. This is synchronous. How do you know? Clock is given here, clock is given here, clock is given here, clock is given here. If clock are given to all the flip-flops, that means all these 4 persons will open their eyes together because they have received the signal together simultaneously. All 4 are getting things together simultaneously. So everything will take place simultaneously because clock is given. Not one after another. It is given to all the flip-flops. That means clock just say tick, 1 tick. It will tick this one also, it will be tick over here, it will be tick over here, it will be tick over here. The same tick sound will be received by all the flip-flops. So all the flip-flops should perform parallelly. That is what I want to say. And let us discuss this in the next class. Okay. If you want, you can study this synchronous counter before coming to the class so that you can ask lots of questions to me. By that way, I can also improve. You can also improve. That is also possible. If you don't have time, if you are busy because lots of internal exams, this and that are coming, then no problem. If you don't have time, also no problem. I will be teaching. So with this, we will wind up. I will give you this material after the completion of the whole counter. I will give you this this thing. I will give it to you after completion of my topic counter. After completion of counter, I will give this flip-flops and all these things. Design of flip-flops, it is also available. That I will copy and paste it over here. Design of flip-flops that we have done in the class. That also I will copy and paste over here, and then I will give it to you. No problem. So, any question? Some students have started giving their attendance very fast. No problem. Nobody wants to study now. That's what namesake. People are attending the class because they are compelled. They are compiled. I should say they have been compelled. I should say to do it as a student, willingly or not willingly. I don't know whether they are joining or not. So those students who have questions, you can ask. I always have time for those students who want to ask questions. And if you don't want to ask questions, also no problem, because it is getting late. If you have questions, I'm here.